right, hey guys, so we are moving on to the last section of the chapter. It is a 2-day lesson, so we're almost there. We're almost to the end. All right, so we're going to look at graphing tangent and cotangent today, we'll just jump right into the tangent function. So the tangent parent function, you're going to, again, use these core points, and then we'll transform them for the transformation functions. So remember, for tangent, the ratio is y over x. So I'm going to be, again, referring to the unit circle, and that's where I'm going to get the points to come up with the correct y values, okay? So you're going to have, I'll draw the unit circle so it makes more sense. If we're looking at the unit circle, 0 to pi is right here. And we have pi over 2. We have pi. And we have 3 pi over 2. And remember, tan is y over x. Okay, and right here the coordinate is 1, 0. Right, this point here would be 1, 0. This point here would be 0, 1. Here I'm going to have -1, 0. And this point down here is 0, -1. Okay, so at tan of 0, you're going to have the y over the x, which is 0 over 1, and 0 over 1 is just equal to 0. And then at pi over 2, again, it's y over x, 1 over 0, which is undefined. At pi, y over x, 0 over -1 is 0. At 3 pi, y over x, it's -1 over 0, that's undefined. And then at 2 pi, it's going to be y over 0, that's 0 over 1, which is 0. Sorry, I was about to say 1. All right, so these points that are undefined, those are going to be the asymptotes of the graph, okay? And if we tried to graph right now, we wouldn't have enough information to know the shape of the graph, which is why we have to extend the graph and look at the pi over 4s, all right? So again, using the unit circle, I'm going to look at pi over 4 and do y over x. That would be √2 over 2 over √2 over 2, which is just going to simplify down to a 1. Then I'm going to go to 3 pi over 4 and look at y over x. That's √2 over 2 over -√2 over 2, which will simplify down to a -1. Then I'm going to go to 5 pi over 4, y over x. Negative over negative is a +1. And then 7 pi over 4, y over x. Okay, so that's where these numbers are coming from. So it's going to be a 1, -1, 1, -1. All right, so that's where the table comes from. And then if I was to graph the parent function for tan, all right, so I'm going to see what I need on my x and my y. So for y, I just need to go up to 1 and down to -1. And along my x, I need the pi over 4. Okay, so what I'm going to do here so that you can understand how to get all these values, let's start with the normal ones that we usually graph. We have pi over 2, then we have pi, then we have 3 pi over 2, and then we have 2 pi. Well, I need the pi over 4s as well. So if you think about it, if you have a pi over 4, and then 2 pi over 4, which pi over 4, 2 pi over 4 would simplify down to 1/2. Then I'm going to have 3 pi over 4. Then 4 pi over 4, 4 over 4 would simplify down to just a 1. Then I'm going to have 5 pi over 4. This is equivalent to 6 pi over 4. Then I'm going to have 7 pi over 4. And then this is equivalent to 8 pi over 4. So the pi over 4s fit in between these values here. All right, now I have everything I need to graph. All right, 0, 0, I plot a point. Pi, 0, I plot a point. And 2 pi, 0, I plot a point. So see what I was saying? I wouldn't have enough information to graph because these are undefined. And where they're undefined, that's where your asymptote is going to be. And we're going to draw just a dotted line. Remember, your asymptote is that line that the graph approaches but never reaches. So I'm going to draw a vertical asymptote at pi over 2, another vertical asymptote at 3 pi over 2. Okay? And then I'm going to keep on plotting these points so I can get the shape of my graph. So pi over 4, 1. Then I have 3 pi over 4, negative 1. Then I have 5 pi over 4, 1. And then I have 7 pi over 4, negative 1. Okay. Now, you don't know really the shape of the graph, so let me explain it to you. The graph shape dips down like this and approaches the asymptote, and then curves up like that and approaches the asymptote. All right, over here, I just have half of the graph, but now that I know the shape of the graph, I could sketch what the other side would look like, and same thing over here. I know the shape of the graph now, so even though I don't have the other points, I can sketch what it should look like, okay? And that is your tan function. So it goes through the origin. The asymptotes are on the pi over 2s, as you can see. Pi over 2, 3 pi over 2. All right. Make sure you curve your pieces like you saw I did. And then try to brush up along the asymptote. All right. Try to get close to the asymptote, but don't actually touch it. Don't cross it. Okay. Last thing we need to talk about is the period and the amplitude. The period for our tan function is pi. All right, and the amplitude, there is no amplitude. All right, there's no amplitude because there is no max and min. It goes on forever in both directions. Okay, there's no amp. I'll just go like this. There's no amp. Because no max or min. It goes up and down forever. So no max and min, no amplitude. Okay. All right, let's look at the cotangent function. Actually, let me just erase this. I'm going to leave this one up to refer to. So for cotangent, remember it's the reciprocal of tan. That's why I wanted to leave that up there. Okay, so I'm still going to use those same core points, 0, pi over 2, pi, 3 pi over 2, 2 pi, and then I'm going to have to extend just like I did over there and use pi over 4. So pi over 4, 3 pi over 4, 5 pi over 4, at 4, and 7 pi over 4. Okay? Now, since they are the reciprocals, all right, instead of 0 over 1, it's going to be 1 over 0. So that means it's going to be undefined. Here, it's going to be 1 over 0, or excuse me, 0 over 1, so that's 0. The next one, the reciprocal, negative 1 over 0, which means it's undefined. Then I'm going to have 3 pi over 0, which gives you the ratio of negative 1 over 0, which is, oh, did I make a mistake? Sorry. I wrote the same thing. I didn't flip it. I didn't get the reciprocal. Sorry, it should be 0 over negative 1, which is 0. And then the last one is 1 over 0, which is undefined. Okay. Now for the pi over 4s, when you flip, think of it was all the root 2 over 2s, root 2 over 2s, all that. It's still going to be all those root 2 over 2s, and it's not going to change the sign either, so none of those change. It stays 1, -1, 1, -1. So that doesn't change. Okay? So when you go to graph, I'm just going to show you the graph, because at this point I think you can do it. When you go to graph, they just look like they're backwards. They're just curved backwards. All right, so that is your tan functions graph, and this is your cotangent graph. Okay? All right, guys, we're going to move on to a transformation graph of tan. Leave the parent function up there so we can refer to it. Okay. So, when we transform, we're going to have y equals a tan bx, where a is going to be your vertical stretch or shrink, and b is going to be your horizontal stretch or shrink. Okay? So just like we did in the last functions, we're going to multiply the y values by a, and we're going to multiply the x values by the reciprocal of b. All right? Your period is going, instead of just being pi, it's going to be pi divided by the absolute value of b. Okay? Remember, there is no amplitude for these problems. All right? So we're going to graph g of x equals 3 tan of 2x. Okay. So I'm going to refer to the parent function and perform the transformations to get my new points for my transform function. The a value tells me there's a vertical stretch of 3, so I'm going to multiply all the y values by 3. It's going to be y times 3. Okay, so 0 times 3 is 0. Undefined times 3 is still undefined. 0 times 3 is still 0. Still going to have undefined. And have 0 again. And then for the extension, it's going to be 3, -3, 3, -3. 3, -3, 3, -3. Alright, for the x values, I have to multiply all my x's by the reciprocal. So the reciprocal of 2 is 1/2. So it's going to be x times 1/2. So all of these have to be multiplied by 1/2. Okay, so 0 times 1/2 is 0. Pi over 2 times 1/2 is pi over 4. Pi times 1/2 is pi over 2. 3 pi over 2 times 1/2 is 3 pi over 4. And 2 pi times 1/2 is pi. Alright, multiplying all of these by 1/2 as well. You're going to have pi over 8. And then I'm going to have 3 pi over 8. And then I'm going to have 5 pi over 8. And then I'm going to have 7 pi over 8. Okay. Now for your amplitude, your period is pi divided by the absolute value of b. The b value is 2, so your period is pi over 2. And we already talked about the transformation. So now let's actually do the graphing, because I want to talk about how to label your x-axis for graphing, the easiest way at least. So what I would suggest doing is look for the smallest fraction, okay? So the smallest fraction is 1/8, all right? 1/8 is smaller than a fourth, 1/8 is smaller than a half. So I'm going to write everything out by 1/8. So pi over 8, then 2 pi over 8, then 3 pi over 8. And you can simplify the fractions as you go or go back through. So I'm going to have pi over 8. Then it will be 2 pi over 8. all right, which would be pi over 4 when you simplify. Then 3 pi over 8. Then 4 pi over 8, which is pi over 2. Then 5 pi over 8, that doesn't simplify. 6 pi over 8 is 3 pi over 4 when you simplify. 7 pi over 8 doesn't simplify. 8 pi over 8 is pi. And that should be enough. That's as far out as I have to go. Okay? All right, and then along my y-axis, it looks like the highest I have to go is 3 and the lowest is negative 3. So there's negative 3 and there's 3. Okay, and then I plot the points. So I have 0, 0, pi over 2, 0, and pi 0. And then I have pi over 8, 3, 3 pi over 8, negative 3, 5 pi over 8, negative 3. Oh, sorry. Did I do something wrong? I just have them off a little bit. 5 pi over 8, 3. And then 7 pi over 8, negative 3. There we go. Let me draw in my asymptotes. So my asymptotes are at pi over 4 and 3 pi over 4. Pi over 4 and 3 pi over 4. All right. And then we know the shape of the graph, so we can curve it down and curve it up. All right, curve it down, and if you want to extend, curve it up. Here, curve it up, and then curve it down. And there you go. All right. Let me erase. Let me see what the next problem was. Probably what I just do. Right hand. This one I just did. All right. So good. We have one more to do, and then we're done. All right. Transformation of cotangent. So we're gonna have right tangent. I had erased the cotangent 4 points, but we're going to need them to do the transformation. So I'm going to jot them up real fast. So 0, pi over 2, pi, 3 pi over 2, 2 pi, then your pi over 4, so pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. And remember, cotangent is the reciprocal of tan, so these are all points. All right, so it's going to be undefined. My goodness, Riley. My daughter's still doing gymnastics. Then I have 0, then undefined, then 0, and then undefined. And then it's going to be 1, negative 1, 1, negative 1. Okay, so that's going to be helpful when we go to transform a cotangent function to have those up there. So we're going to look at g of x equals cotangent of pi over 2x. All right, so there's no a value here, so we're not multiplying the y's by anything. But we're going to multiply the x's by this reciprocal of 2 over pi. Okay, so we're going to multiply all the x's by 2 over pi. All the y's are unchanging, so I can just copy them down. It's undefined, 0, undefined, 0, undefined, and then it's 1, negative 1, 1, negative 1. All right. Now, all of these have to be multiplied by 2 over pi. Okay, so 0 times 2 over pi is just 0. Pi over 2 times 2 over pi, if you need to write it out, you can. Pi over 2 times 2 over pi is 1. Then pi times 2 over pi, the pi's cancel, leaving you with a 2. Then 3 pi over 2 times 2 over pi, The pi's cancel and the 2's cancel, so it's a 3. And once you see the pattern, you don't have to write it all out if you don't need to. So 2 pi times 2 over pi. The pi's cancel, multiplies 2's to get 4. Then it's pi over 4 times 2 over pi. The pi's cancel. It will be 2 over 4, which is 1/2. Then it's 3 pi over 4 times 2 over pi. The pi's cancel. You're going to have 6 over 4, which simplifies, right? Both are divisible by 2, so that's 3 over 2. All right? My arm is hurting, guys. Sorry. And then it's going to be 5 over 2 and then 7 over 2. 5 over 2 and then 7 over 2. Okay? All right. And again, I think you can probably at this point handle the graphing. So I'm going to take a shortcut and just show you the graphing. Again, my answer key is there for you to look at. Okay, last thing we're going to do is talk about the period. The period, remember, is 2 over the absolute value of b. So that's 2 over pi over 2. It's ugly. You can't leave it like that. It's a complex fraction. So write it out as 2 times the reciprocal, which is 2 over pi. So that's going to be 4 over pi is your period. Okay. What did I do wrong? What did I do wrong? Oh, I wrote it. Guys, made a mistake. Sorry. Let me backtrack. I wrote the wrong period. I don't know what I was thinking. It's not 2 over absolute value of b. It's pi over the absolute value of b. I'm rushing. Try that again. It's supposed to be pi divided by the absolute value of b. So it's pi divided by pi over 2. So it's pi times 2 over pi. The pi's cancel. Your period is 2. Alright. Alright guys, so that is the last bit of day 1 of lesson 9.5. We just have one more lesson to go and then we'll be done. So I'll see you back here for day 2.